Okay, here we go. Degrees, minutes, seconds. Up to this point, when you're talking about an angle, most of the time they've been whole number angles, 30 degrees, 48 degrees, 57 degrees, 123 degrees, whatever. Degrees, minutes, seconds, I think of it like this. Degrees, minutes, seconds is a fine-tuning. It's kind of like if you're talking about, maybe you're turning a telescope or something. And see if you can picture this. This is my picturing of this. Let's say you've got a telescope and you're turning this thing to where degrees, if you turn that degree knob, it changes like from 28 degrees to 29 degrees to 30 degrees, changes it majorly. Then what if you had a minutes knob and a seconds knob? Those two knobs would kind of fine tune it to where minutes, what a minute is, well, we know what a minute is. When we're talking about clock, well, it's the same thing here. You have degrees, full degrees, which would be kind of like our hours on the clock. And then you have minutes, which is kind of a breakdown. Between degrees, you have minutes. And then you've got this small knob over here that actually fine-tunes it even more. And maybe you've got that telescope turned to right nearly where it needs to be, but it just a smidge is all you need. You can come over here to the second knob, and you can start turning that second knob so where it just barely turns that. So minutes and seconds are your divisions between degrees. Up to this point, if we didn't have a whole degree, we called it like 28.3 degrees. This is not in minutes and seconds. That's just in decimal. That's 28 degrees plus a little bit more. Okay, but we're going to change this thing to where instead of just 0.3, instead of decimal notation, we're going to change it to degrees, minutes, seconds notation. There are 60 minutes in a degree. So a minute is 1/60th of a degree. There are 60 seconds in a minute. So you have degrees, 1/60th of a degree is equal to a minute. And since 1/60th of a minute is a second, we're going to say 1/3600th of a degree is a second. So there's 60 minutes in 1 degree. There are 3,600, because there's 60 60s, there are 3,600 seconds in a single degree. Here's your notation you see, and this is a GPS location of actually the school. We're somewhere, I believe, right in here. We are at 34 degrees, 34 minutes, 55 seconds. And that's your abbreviations there, the tick marks, or the single mark and the double mark there. North, 85 degrees, 58 minutes, and 48 seconds west. That's our MapQuest location. And here you see, I've got this other picture. Each degree is divided into 60 minutes. Each minute is divided into 60 seconds. So you see here a blown up picture of a protractor. And just to know, kind of, it's the same thing as a tape measure, that you have 41, 2, 3. This is 43 degrees. This is 44 degrees. If you're in between, you've got 60 little tick marks, 60 lines there that would also measure minutes. And between each of those 60 minutes, between each of those lines, you would also have 60 lines measuring seconds. But we don't have that on the protractor because we can't zoom in that far. Okay, changing from degrees, minutes, seconds to decimal form, one of the easiest things you've done the entire year. Here you have 34 full degrees plus. You have 37 minutes. 1 minute is 1/60th of a second, so you actually have 37 60ths of another degree. Does everybody understand where that came from? There's 60 in a full one, so you have 37 of the 60 when you have 37 of the minutes. Plus, you have 22 seconds, which is very minor. This right here means very, very little. 22 out of 3,600 that takes to make a full one. So 34 full degrees, 37/60ths of a degree, 22/3600ths of a degree. You type that straight into your calculator and you're finished. That changes you from, here you go, let me turn my calculator on. That changes from, this is called DMS, degrees, minutes, seconds form, DMS form to decimal form, 34 plus. But really the only caution I have for you is make sure you put in parentheses 37/60ths plus another 22/3600ths enter. 34.6227 or 6228. So a little bit over 34.6. Okay, that's in decimal form. That's the form that you're used to seeing, not degrees, minutes, seconds. Okay, now let's go backwards. And you might not see this, but in this problem, we're actually going to have to know what the word of means in math. And you all know that anytime you see the word of in math, that you're talking about multiplication. So here, and I'll show you where that comes from. Here, you have 44 degrees and then some. You have 44 full degrees plus an additional 0.235 of another degree. So since you have 44 full degrees, let's go ahead and write that down. 44 degrees. We've taken care of the 44. 44 full degrees. 0.235 read as a fraction, or really read period, is 235 thousandths. Okay, tenths, hundred thousandths, 235 thousandths. We don't have another degree, but we have 235 thousandths of another degree. That's going to be our minutes. And eventually it's going to turn into our seconds. We know that there are 60 minutes to complete a full degree. We don't have all 60. We have this portion of the 60. There's that word again. So how do I find this portion of the 60? We multiply them. So in your calculators, take out, and we're going to type in 0.235. 0.235 of the 60, and that tells me that we have 14.1. We have 14 full minutes with a little bit left over. So the 14.1 is how many minutes we have. So what I can say now is I have 44 degrees, I have 14 full minutes, mark it out, and I have another portion. That portion is your seconds. So you have 0.1 of another minute, because this is 14.1 minutes. You have 0.1, or a tenth, of another minute, and each minute we know has 60 seconds in it. But we only have 0.1 of those 60 seconds, so again you multiply. 0.1 times 60, I believe you get 6. So written in DMS form, degrees, minutes, seconds form, we have 44 full minutes. We have 44 full degrees, 14 minutes, which we know there's 60 in a whole degree, but we only have 14. And then an additional 6 seconds, 6 out of 60 to make this 15. And you can see, maybe it makes sense if you saw it counting up. This would be 6, 7, 8, 9, 10. Once you get to 59, 60, that would move this up to 15. Then you'd start over 0, 1, 2, 3. Up to 60, that'd make this a 16 then. Once this hits 60, that would move this up to 45 degrees. Okay, let's do another one of those the quick way. Let me make one up. Let's do 23.875. Actually, let's do negative 23.875. Just so I can show you something. If you have a negative angle, please just forget about it to begin with and go back and tack it on at the end. Okay. So if you have a negative angle, forget about it and do 23.875, work out the problem, and then go back at the end, because you might have some negative positive issues if you don't. Here's the entire problem worked on the calculator. 23.875. We have 23 full degrees. Let's go ahead and take those off. We're left with a 0.8375, or excuse me, 0.875. That's 875 thousandths of another degree. You take that 0.875, you multiply it by 60. Enter. That's 52 minutes with a little extra. Okay? Take the little extra, so go ahead and take away the 52 off of that. Take the little bit of extra, multiply it by 60 again. Gives you 30. So we had, what was it, 52 minutes. So this was 23 degrees, 52 minutes, and was it 30 seconds? And now go back and put the negative on. Negative 23 degrees, 52 minutes, and 30 seconds. Moving on. Radians. Up to this point, the majority of the angles that you have been measuring, and did y'all deal with radians in Algebra 2? Y'all remember? Maybe. Up to this point, every angle that you have dealt with has been pretty much in degrees. There are two ways of measuring angles, and that is with degrees, well, up to this point. What we're going to talk about, degrees and radians. What a radian is, see if you can picture this. If you took a radius, whether it be a radius of 3, radius of 4, whatever, if you took a radius and you laid it on the circle and you curved it around the circle, the angle that you just cut off, which is about that big, right, is called a radian. And you might be saying, well, with bigger circles, since they have bigger radiuses, or radii, wouldn't bigger circles have bigger radians? No. Because if you blew this thing up, well, here you go. Watch this. I just made that circle bigger. Did I make that angle bigger? Watch that angle. Watch the opening. No matter how big or how small the circle gets, the actual angle, the opening's the same. Okay, no matter how big your circle is, no matter how small the circle is, the opening's the same. If you lay the radius on the circle, the angle will always be the same. It is called 1 radian. And a radian, you don't have to know this, but a radian is somewhere around 57 degrees. Here's what you do need to know. You put this in your notes, start, make sure you know this. Here's the important part. Let's say, let's make this make sense to you. What if this has a radius of 1? If this has a radius of 1, if you remember from geometry, circumference. Circumference is equal to pi times diameter. If the radius is 1, the diameter would be 2. So the distance around this thing would be 2 pi. Well, again, picture that radius being laid on here. I don't want all the way around. What about halfway around? This angle here, or this rotation, would be a single pi, okay, which is what 180 degrees is equal to. 1 pi radians is equal to 180 degrees. Pi equals 180. So not only does pi equal 3.14, now pi does equal, or it's about 3.14, and if you're talking about radians, that will equal exactly 180 degrees. 3.14 radians is equal to 180 degrees. If you have 3.14, take this radius, you lay down about 3.14 of them. There's a radius, there's a radius, there's a radius, there's the 0.14. 3.14 radii will always give you half of that circle. So 180 degrees, or half the circle, is equal to 3.14 radians. Conversion between radians and degrees, and this is going to be big on your next test. How to convert, how to switch back and forth between radians and degree measures. If you remember this conversion factor, some of these are extremely easy. This is in radians. The reason we know it's in radians, we don't see any degree measures. This pi right here, on these problems, the easy way of doing this, take out the pi, put it on 180. So instead of 7 pi over 6 radians, that's 7 180 over 6 degrees. Now let me show you a shortcut. I want you to get to where you can do these in your head without calculators. And you might be thinking, yeah, right. Watch this. Pi over 6. Let's go over your common angles. Pi divided by 6, and these are the ones you really need to know. Pi is 180. Can everybody can divide 18 by 6 in their head, no problem. Okay, we've been doing that since 3rd, 4th grade. If you can divide 18 by 6, you can divide 180 by 6. How many degrees is this? 180 divided by 6 is 30 degrees. This is what a 30-degree angle looks like in radians. Okay, let's do another one. Pi over 3. If you can divide 18 by 3, you can divide 180 by 3. 180 divided by 3 is 60. That's what a 60-degree angle looks like. Pi over 2. Same thing. If you can divide 18 by 2, you can divide 180 by 2. 180 divided by 2 is 9. And the one that is a little bit tougher, pi over 4. Think of it like this. You're going to divide by 2 and divide by 2 again. Pi divided by 4 is the same thing as divide by 2 divided by 2. Well, we already divided by 2 once. Pi over 4 or 180 divided by 4 is, anybody know? 45 degrees. That's your common angle. A lot of people's going, well, what about 0? That's 0. Okay, 0 and 0, same thing. If you want to write that as 0 pi over 6, don't. Okay, it's 0. So there's all your common angles that we've been doing. Now let's go to this problem that I just put up here. 7 pi over 6. This is not pi over 6, this is 7 pi over 6. Clean up. Here's my shortcut. Just do that first. If you can do 18 divided by 6, you can do 180 divided by 6. 18 divided by 6 is 3. What is 180 divided by 6? 30, right? Guys, this is simply 7 30s. If you can do 7 times 3, you can do 7 times 30. 7 times 3 is 21. 7 times 30 is 210 degrees. So my advice for you, I know that you can do pi over 6, you can do pi over 3, you can do pi over 4, you can do pi over 2 in your head. So once you've done that part in your head, the pi over 6 or pi over 2, pi over 3, just multiply it by the number that's out there with it. Okay, that's it. 7. So this is 7 30s or 210. Let's do more. Let's not do those yet. I want to do more of these. Let's do 3 pi over 2. Again, do the pi over 2 part first and multiply it by 3. Pi over 2, let me get your name cards here. Noah, what's pi over 2? And give me 3 of those. 390, is 270 degrees. Everybody understand that? Let's do one more. Tootin, 5 pi over 3. Do the pi over 3 part first. What do you get? Careful. 18 divided by 3 is 60. 5 60s is 300 degrees. So 5 pi over 3 is the same thing as 300 degrees in degrees. Okay? Any questions there? Here's another way of working this, because look at this next problem. There's no pi's. There's nowhere to plug in that 180. We don't like these. Okay, they're not as fun. You have to use calculator. Well, you don't have to use calculators. If you would like to go back and use some of your multiplication of decimal skills back from 6th grade, that is so valuable now. Okay, 12.3 radians. And converting this to degrees, but there's nowhere to plug that pi. It's not 12.3 pi. What they've actually done is maybe it used to be like 4 pi or something like that, and they multiplied it out. And that would actually be 12.56, but they multiplied it out and they've got just decimal now. So how do I do it when I have just decimal? Let's go back to chemistry and let's talk about conversion factors. If you take a fraction, such as 2/3, here's, for those of you that maybe haven't had chemistry or don't remember chemistry, if you take a fraction and you multiply it by 1, it does not change that fraction. If I take this fraction and I multiply it by 5 over 5, it does not change that fraction. That's multiplied by 1. Okay, that's 10 over 15. It didn't change the fraction, it put it in a different form. That's what we're going to do with these problems. These are called conversion factors. Conversion factors are simply ones that you multiply your fractions by to change, or in this case, decimals. I've already told you that pi radians, 180 degrees, is the same thing. Here you have 12.3 radians. I'm going to multiply 12.3 radians by 1. 180 degrees and pi is the same thing. I'm multiplying by 1. That's legal. This will not change 12.3. It'll simply change the form that it's in. Here's the number one thing to make sure of, though. Radians are on top, radians are on bottom. Those will cancel out with each other. If you remember to do that, and that goes for your chemistry stuff too, if you want to change miles per hour into kilometers per second, remember how to do that, hopefully. You just have a big string of conversion factors being multiplied by it. These are simple one-step conversion factor problems. Radians cancel. To multiply this out, you would type into your calculator 12.3 times 180 divided by 1 times pi. Now this pi is the 3.14 pi. That's fine. Go ahead and plug that in. Don't leave it as pi form. And a lot of people will be like, well, do you want me to sub 180 in for it? That kind of defeats the purpose. Because then you'd be multiplying by 180 over 180, which is 1, which I think you get 12.3 back if you do that. So 12.3 times 180, divide your answer by pi. Kobe, have you got that yet? Tell me when you get it. 7, say it again. 705.1. We'll call it just 705. 705 degrees. And again, radians canceled. This answer is in degrees. 705 degrees. Now let's see if that makes sense. Does somebody else back that up? Oh, good. .3 radians. I told you, let's talk radians. Remember graphing our angles on Friday? This is 0 degrees, which is the same thing as 0 radians. This is 180 degrees, which is the same thing as pi. Remember that? If you took, and at 90 degrees, that'd be half a pi, because this is a whole pi. A half a pi would be 1.57. And I think if you multiply it by, let's see, I know that this would be 6.28 as you come around, because that'd be pi and 2 pi's. This would be 4.71, I think. That's in radians. So 0 radians, 1.57, which is half of 3.14. 3.14 radians, 4.71 radians, 6.28 radians. We were asked to do 12.3. That keeps going. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So obviously at 12.3, it looks like it's nearly 2 rotations, isn't it? Because if 6.28, that's 2 pi's. Pi is 180. 2 pi's would be 360. That's 2 pi or 360 degrees. 12.3 is nearly double that. 6.2 doubled is like, well, that'd be 12.56 would be 2 full rotations. So it's not quite 2 full rotations. The same way that this is not quite 2 full rotations. 360 would be 1 full rotation. 720 would be 2 full ones, but that makes sense. That's a reasonable answer. Now let's do it the other way. Degrees to radians. Negative 23.6 degrees is about right here. Negative 23.6 degrees. Again, forget about the negative, and let's just worry about the 23.6 degrees, and then we'll put the negative back with it. 23.6 degrees. To turn that into radians, you do the same thing, guys. You multiply by 1. 180 degrees I'm going to put on bottom, because degrees I want to cancel with degrees. Pi radians I'm going to put on top. Degrees cancel. In your calculator, you do the same thing just backwards. You're going to take 23.6. Logan's not here. Allie, tell me when you get this. You're going to take that 23.6. You're going to multiply by your pi. Get your answer and divide that by 1 times 180 or just 180. And I'm guessing you're going to get somewhere around, let's see, 1.57 would be 90 degrees. That's nowhere near 90. That's about a fourth of 90. A third of 90, somewhere between a third and a fourth. Yeah. 0.412, is that what you said? And since it's negative, now we can put the negative back with it. So nowhere near 3.14. Nowhere near the 180 degrees. Nowhere even near the 1.57 or 90 degrees. and 0.4 does make a logical argument. Bless you. Now, there's two ways of working this one. I know that 270 is one of my common angles, right? Your common angles in first quadrant, 30, 45, 60, and 90 degrees. Pi is 180. So let's go through one more time just as a reminder. 30 degrees would be pi divided by what? 6. 45 was pi divided by 4. 60 was pi divided by 3. And 90 was pi divided by 2. Correct? Does everybody understand that 90 will actually divide into 270? Watch how easy this is. 90 is pi divided by 2. Well, how many 90s is this? 3 90s. Done. That's the easy way of working it. And a lot of people say, well, but what about 30? Could I not use 30? If you want to, it's just going to make it longer. 30 was pi divided by 6. How many 30s is this? Reduce it, you get 3 pi over 2. Same answer. Okay. So if you want to work at that, that's my shortcut way. Just knowing that pi is 180, knowing your common angles of 30, 45, 60, 90. Let's work another one of those. It's a little bit tougher. Let's do 150. Jordan, which one of those will divide into 150? 30. And 30 is pi over 6. Right? Jordan, how many 30s is in this? 5 30s. That makes sense. Now, again, that's your shortcut. That's the easy way of working it. One more of those. 60. Let's do 300 degrees. Because two different people might work this two different ways. Daniel, which one of those will divide into 300 degrees? 60. How many, let's say 60, that would be pi divided by 3, right? It's 60. Daniel, how many 60s is this? 5. 5 pi over 3. Let's do it the other way. Did anybody work it another way? Anybody want to use 30, right? 30s would be pi over 6. How many 30s is it? And then we'd have to reduce 10 over 3, or 10 over 6, and what we get? Same answer. It doesn't matter which one you use if it's a multiple of it. If you did not recognize that, here's how you work this. This is how the book's going to show you. I don't like this. Okay, I like the shortcut. But here's how the book will work it. 270 degrees, conversion factor, 180 degrees, and pi radians. Degrees mark out. You could do 270 times pi divided by 180, but that's going to give you a decimal. What they're going to want you to do is take this 270 and 180, reduce it, divide by 10, divide your result by 9, gives you a 3 and a 2. You're left with 3 pi over 2. Okay, same answer. I would much rather just use, I know this is a multiple, so do it that way. But work it either way you want to. But just keep in mind, we want to leave the pi if we can. It just makes it cleaner. You don't have, because we know that pi is irrational. As soon as you plug that pi in, all of a sudden we have ugly decimal. So leave pi if possible. If not, go ahead and plug in the 3.14 for pi. 210, that's 7 30s. That's a whole lot faster than the book can work it, I promise. There's, and you don't have to write these down, there's a combination of what we've done before. There's your 30 degrees, which was your pi over 6, your 45, which is your pi over 4. Comes down here, 330 maybe. Pi over 6 was 30, that's 11 30s. 5 pi over 3, that's 5 60s, which is 300. 225 degrees. Pi over 4, that's 45 degrees, that's 545 degrees. One thing I do want to point out is notice that all your red angles, all your multiples of 45 are the pi over 4 angles. You have 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. What about 2 pi over 4? I believe 2 and 4 are reduced to a half pi over 2, which is 90. 4 pi over 4, I believe 4 4's are canceled, that's pi. Okay, so you see the relations, see the connections. Okay, nearly finished, guys. Coterminal radians. Now let's go back and do everything that we've done before, except for with radians now instead of degrees. Coterminal angles were angles that had the same terminal sides, such as 0 degrees, 360, 720, 1080. Those were coterminal because they had the same ending place. Whether you dunk with a 360 or you dunk with a 720, you're still facing the rim when you dunk the ball, right? Or a 1080. That'd be awesome. If you want to try your 1080. Find 2 positive and 2 negative coterminal angles of pi over 6. I'm going to be completely honest with you. I really don't like working with radians. Most of the time what I do is I change them to degrees, and I do them and work with them, then I change them back to radians, just because I don't like working with radians. But we will show you how to do this. Find 2 positive and 2 negative. Okay, when we were dealing with 30 degrees, which is the same thing as pi over 6, how did we find coterminal angles? What, Anna Marie, did we add to the 30 degrees to give me coterminals? What did you add to it, or what did you take away from 30 to give you a coterminal angle? A rotation, which was, careful, full rotation, 360. So we added 360 to this, and that gave me 390, remember that first lesson, which was coterminal. I don't add 360 anymore. Somebody tell me what I add. 2 pi. If you're dealing with radians, that's 2 180s, or 360. When you're dealing with radians, to add a rotation, a full rotation is 360 degrees, or 2 pi radians. You need common denominator, which is 6. You have now 13 pi over 6. That's coterminal. Add another 2 pi, which would be 25 pi over 6. To find the 2 negative coterminal angles, you do the exact same thing, except for you subtract them. You have 1 pi over 6 minus 12 gives you negative 11 pi over 6. Subtract 12 pi over 6 again gives you negative 23 pi over 6. There's 2 positive and 2 negative. If you want to check me, 13 pi over 6, that's 13 30s, will be your 390. If you did 25 pi over 6, that'd be 25 30s, which is 750, which is what you would get if you added 360 again. The only thing with changing it to degrees and doing these with degrees is you're going to have to take a number like 750 and change that back to radians. That's not as fun. Negative pi over 3. We want to find 2 positives and 2 negatives. That's the same thing. This is negative 60 degrees is what you're dealing with here. In order to find coterminal angles, we're adding rotations. We're adding 2 pi's. Common denominator here, multiply top and bottom by 3. That gives me a 6 and a 3, so 6 pi over 3. And you can check that. 6 divided by 3 is still 2 pi. So we're going to add 6 pi over 3. That gives me negative 1 plus 6 is 5 pi over 3. There's one answer. Add 6 pi over 3 again. Gives me 11 pi over 3. There's your 2 positives. To find your 2 negatives, you have negative pi over 3 minus 6 pi over 3, which is negative 7 pi over 3. Subtract 6 pi over 3 again is negative 13 pi over 3. In degree measures, this is 5 60s, which is 300. This is 11 60s, which is 660. This is negative 7 60s, which is negative 420. This is negative 13 60s, which is negative 780. That's your degree measures for the exact same radian measure.